Okay, here we are, problem 36, page 418. I believe this is, well, it's the last of the three problems that we've done on page 418. You may spend some time on that page to make sure you've got this graphing skill down. This is problem 36, and it is a sister to problem 32 on your homework set 28. This is to graph cosecant 3 pi over 2x equals y. And so the technique I'm using is, in this case, I'm trying to show the relationship between the sine and the cosecant. I'm essentially deriving the graph of the cosecant from the graph of the sine. Right? If you can draw a squiggly wiggly, you can draw a sine or a cosine. And then with a little reasoning, you can come back and draw the other four trigonometric functions, and that's what we're trying to show here. So the manner in which I'm doing it is I'm kind of recognizing that the sine, one period of the sine, has got a couple things going for it. It starts at 0, it goes up to its maximum at pi over 2, it goes back down to 0 at pi, and then down to its minimum of -1 at 3 pi over 2. So if the argument of the sine was just x, it would go from 0 up to 1 at pi over 2, back to 0 at pi, down to -1 at 3 pi over 2, and then complete its first cycle back to 0 at what is essentially 2 pi. That is for sine of x with a period of 2 pi. We were dealing with that, but we're not. We're dealing with the trig functions, the sine and cosine trig functions and their reciprocals, which have this constant factor of 3 pi over 2 multiplying x. In that case, remember, the period is 2 pi all over this constant factor, which we're going to call omega here in this case, where omega is 3 pi over 2. So let's compute the period to start off. That says the period is equal to 2 pi all over 3 pi all over 2. That's equal to 4/3, is it not? The 2 goes up there. Yeah, it's 4/3. So one period of sine of 3 pi over 2 times x ends here at 4/3, which means that this value is 1/3, this value is 2/3, and this value is 1 right here. Let's just carry those all the way down here. And we'll come back and check that just to get comfortable with it as we move along. But let's go ahead and just draw the sine. Like I said, sine of 0 is 0, goes up to its maximum in the first quarter cycle, back down to 0 in the second quarter cycle, back down to its minimum, in this case -1, in its third quarter cycle, and there finishes out its first period with its first quarter cycle. So what does cosecant do? Cosecant is the inverse of this function. Yeah, it's the reciprocal, the reciprocal of this function. So let's see what this function is doing. As it's going from the end of its first quarter cycle at 1/3 back to 0, it's getting uncomfortably close to 0. And remember that this thing we're trying to graph, 3 pi over 2 times x, is the reciprocal of the sine of 3 pi over 2x. So as sine gets uncomfortably close to 0 on the positive side, right? I'll show you an occasion right here where it gets uncomfortably close to 0 from the negative side. But as the sine gets uncomfortably close to 0, the cosecant gets uncomfortably close to infinity. Yeah. And then what happens at this maximum value of 1? Well, 1 over 1 is 1, so the cosecant gets uncomfortably close to 0 and ends up at 1. In this case, the cosecant looks like this. Now, over here at the end of the second quarter cycle, which is at x equals 2/3, the sine is decreasing and getting closer and closer to 0, And so 1 over the sine is increasing and, leaping up without bound here. Right, so let's do the same thing over here. What's happening here? In between this third and second quarter cycle, if we look back this way, the sine is actually increasing, if you will. It's getting closer and closer to 0, but from the negative side. So cosecant is going to pick up that negativity, and as the sine gets closer and closer to 0, the cosecant is going to be negative, heading towards negative infinity. As we get here to -1, 1 over -1 is -1. That's where we are right there, and then back down. And there's a cycle of the cosecant. We'd pick up the other cycle starting right here, like that. Okay? Okay, I hope that's understandable.